calculating probability, it's important that we are able to count up all of our options or all of the different ways that a particular event can occur. So that's what this video is all about, counting. Specifically, we're going to go over the multiplication counting rule and the factorial rule. We'll start with somewhat of a silly example. Suppose a person has 6 shirts, 4 pairs of pants, and 2 pairs of shoes. How many distinct outfits can be made? Let's think about these options. They need to choose a shirt, a pair of pants, and a pair of shoes. They have 6 shirts to choose from. And after they've chosen a shirt, they now get to choose 4 pairs of pants. And finally, they have to choose from their 2 pairs of shoes. You could create a tree diagram to show this situation and see how many different options there are. Or you can consider that for each shirt option, there's 4 pants options and 2 shoe options, and multiply 6, 4, and 2 to get 48 distinct outfits. This is the idea of the multiplication counting rule. If we have a sequence of 2 or more events, which in our example we had 3 events, choosing a shirt, choosing a pair of pants, and choosing a pair of shoes, if the first event can occur in n1 different ways, that was our shirt options that could happen in 6 different ways. The second can occur in n2 different ways. Those were our options for pants, which can happen in 4 different ways. And a third event can happen in n3 different ways. Those were our options for shoes, which could happen in 2 different ways. And so on for any number of events. The total number of different groupings of these events in which one is selected from each group is the product of n1 times n2 times n3 and so on, depending on how many different events you have. In our example, we had 3 events and we multiplied the different ways that each event could occur because we were selecting one from each group. Let's look at another example. How many different license plates can be made using California's current pattern of number, letter, 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 number, number, number? This is exactly the pattern that was in place when my license plate was created. Let's think about how many different license plates could be made this way. First, we have a number, then 3 letters, followed by 3 more numbers. Assuming we can use the digits 0 to 9, we have 10 options for each number. And assuming we can use all 26 letters of the alphabet, there are 26 options for each letter. And using the multiplication counting rule, we can multiply all of these values together. We have 4 copies of 10, or 10 to the 4th, and 3 copies of 26, or 26 to the 3rd. And putting that into our calculator, we can find that there are 175,760,000 different license plates that can be made with this pattern. One notation that often comes up when we're counting is factorial notation, which is the exclamation point. And that denotes the product of decreasing positive whole numbers. For example, if we want to find 8 factorial, we want the product of 8 and every other whole number that comes before it. So we have 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, or 40,320. You can also calculate this on your calculator. And if you're using a TI-83 or 84, you'll want to click the Math button, toggle over to Probability, and then select option 4. This brings us to the factorial rule. The factorial rule states that the number of different arrangements, and by arrangements we mean order matters, of n different items when we're selecting all of them is n factorial. For example, Kara's visiting 6 different colleges but is not sure in which order she should visit them. How many possible orders are there? Notice that we have 6 different items, so n is equal to 6, and we're going to select all 6 of them. She's going to visit all 6 colleges. We simply want to know how many different arrangements or orderings there are. And using the factorial rule, we know that there are 6 factorial, or 720 possible orders that she could visit these 6 colleges. Looking at this through a slightly different lens, think about how many options she has for which college she goes to first. 6. After she's visited the first college, how many are left to choose from second? Now there's 5. Once she's visited 2 colleges, how many colleges are left to choose from to visit third? 4, and so on. Multiplying these values together, we have exactly 6 factorial, or 720. That concludes this lecture video on a few methods of counting.